In this video, I want to have a look at some problems that involve products and sums of trig functions. So our first example asks us to convert cos 3a cos 5a into a sum of cosine functions. So the rule that we're going to use for that is we know that if we have cos a cos b, we can rewrite that as a half outside of cos of a minus b plus cos of a plus b. So in our question, our a would be 3a and our b would be 5a. All right, so using that, we can say that cos 3a cos 5a is equal to, and we're just going to substitute in here. So we'll end up with a half outside of cos of 3a minus 5a plus cos of 3a plus 5a. So then we can go and simplify that down. So we'll have a half outside of cos minus 2a plus cos of 8a. Now this cos of minus 2a, we know that cos is an even function. So that is just equivalent to cos, still need that square bracket, still equivalent to cos of 2a. And we still have our cos of 8a as well. So that's converted it from a product of cosine functions to a sum of cosine functions. Our second example asks us to show that sine 35 minus sine 25 is equal to root 3 sine 5. Okay, so we're going to rewrite this left-hand side of this equation. What we need to think about is when we're looking at things like this, we're thinking about that a plus b, a minus b. And we want to figure out what numbers add together to give 35 and subtract to give 25. One of the things that can give us a hint is what we're aiming for over here with this 5. So the way we can rewrite this is into sine of 30 plus 5 minus sine of 30 degrees minus 5 degrees. Once we've got that, we need to think back to our rules. And one of the rules that we have is that if we have cos a sine b, that's equal to a half outside of sine a plus b minus sine of a minus b. Now, if we were to rearrange this, we could times both sides by 2, so we'd get rid of that half and we'd end up with a 2 instead. Now, what we have over here looks very similar to what we have in our problem. So we're going to go from this right-hand side and we're going to manipulate it to look like this left-hand side here. So we're going to end up with 2 cos. Now, in this case, our a's were 30s and our b's were 5s. So we're going to have cos 30 degrees, sine 5 degrees. Now, we know that cos 30 from our exact values, cos 30 is root 3 on 2. And we've still got our sine 5 degrees on the end there. And of course, that will simplify down. Those 2's simplify. So we'll just end up with our root 3 sine 5 degrees, which is, of course, our right-hand side of that equation. Our last example asks us to prove that sine 5x plus sine 3x minus 2 sine 2x cos x is equal to 2 sine 2x cos 3x. All right, so we're going to start with the left-hand side of this and manipulate it until we end up with the right-hand side. All right, so we're going to start with this left-hand side. And first, I'm going to look at rewriting these first 2 terms. So that 5x and 3x, we could get both of those using a 4x and an x. So I'm going to rewrite them as sine of 4x plus x plus sine of 4x minus x to give us that 3x. And I've still got my minus 2 sine 2x cos x on the end as well. All right, so then using one of our rules to convert between products and sums, I'm not going to write it down this time, but using one of those rules, we would end up with 2 sine 4x cos x. And we've still got this chunk on the end as well. Okay, so that's simplified that bit down into one term. It's always useful to have a look at what we're aiming for. I know that we've got a sine 2x in our answer, and I already have one of those here, so I don't really want to touch that unless I have to. We could manipulate this sine 4x into a sine 2x as well. We could write that as a 2 sine of 2 times 2x cos x minus 2 sine 2x cos x. All right, now this is a double angle, so we can expand that out. So we're going to have our 2 that's already here times, with that double angle, I'd end up with 2 sine 2x cos 2x. And I still have this cos x on the end as well. And then we've got this whole second term here. Now I'm going to pull out a 2 sine 2x out front as a common factor. So then in here, I'd end up with a 2 cos 2x cos x minus cos x. Okay, so leaving the term out the front as is for now. This is looking good. This is looking like this whole first chunk, but we've got to get what's in the brackets now looking like this cos 3x on the end. So this first term inside the brackets is, again, we can apply one of our products to sums rules to that. So what we're going to end up with in that bracket is a cos of 2x minus x plus cos 2x plus x, and we've still got that minus cos x on the end. So simplifying those, we'd have a, not a sine, we'd have a cos x plus cos 3x minus cos x. Those two there are going to cancel out, so we'll end up with our 2 sine 2x cos 3x, which is our right-hand side that we were aiming for. So again, that's not the only method that you could use to solve this problem, but it is one of them. So that's having a look at a few problems that involve products and sums of trig functions.